Welcome back to this new tutorial. In this video, I want to show you how we can melt any object by using geometry nodes in Blender without having to do any simulation. Let me show you. Okay, so first of all, you need to bring in the object that you want to melt. In this case, I'm going to demonstrate this with this 3D model of this chocolate bunny that you can actually download for free with the link in the video description. One thing that you need to consider when selecting your object is that you need to have the origin point at the bottom of the object. So in order to make sure that this is the case, simply place the object on top of the origin of the world and then simply press Ctrl A and apply all transforms. So now we are ready to get started. So let's make this window down here a bit bigger, and I'm going to switch this to the geometry node editor. And then let's click on this plus in order to create a new node tree. And I'm just going to rename this to melt. The first thing we want to do is create a boolean that we can use to cut away the bottom part of our object. And for this boolean object, we want to have a cube that has exactly the size of our object. This is pretty easy to do with the bounding box node. And you can see this if I bring in a join geometry node. So we can see both objects at the same time, that this cube now has exactly the same size as our object. However, we don't want this cube to cover our object. Instead, we want it to be on the bottom. So let's bring in a transform node. And we want to bring this down on the Z axis so that this is on the bottom of our object. And we can do this exactly by using this max output of the bounding box. However, if we connect this directly to the translation input, you can see that it also moves it on the Y and X axis, and it also moves it up instead of down. So to fix this, we want to use a separate XYZ node, plug this in here, and then also use a combine XYZ node and bring this in here. Now instead of the X axis, we want to connect this Z axis. And now you can see that it is only moving it on the Z axis. However, it is still going up instead of going down. So let's fix this by bringing in a math node. Place this in between the separate and combine XYZ node. Switch it from add to multiply and change the value to -1. And now you can see that this is perfectly placed on the bottom of our object. Now I think we can make this a bit bigger on the X and Y axis in order to avoid any errors later on. So let's go to the scale values and just increase the X and Y values just a little bit. And now we can start using this as our boolean cutter in order to shrink our object. So let's remove this join geometry node, and instead we want to use a mesh boolean. Plug the original geometry in the top input and our boolean cutter into the bottom. So now when we take a look at this output mesh, you can see that we get our object. However, now it is going to cut away everything that goes lower. So let's take a look at this by bringing in another transform node, place this here. And once we start to transform this on the Z axis, you can see that our object starts to melt away. Now I want to be able to control this melting value directly from within the properties of our geometry node modifier. So in order to do this, let's bring in another combine XYZ node, so we get direct access to this Z value. And now in order to control this directly from a group input, we want to bring in a mix node. Then connect the group input to the factor. And in the beginning, we want this set to have a value of 0. So make sure that the value A is 0. And for the factor B, we want to use exactly the same value that we used in order to transform our bounding box. So let's connect this up to the B value and then plug this mix into the set of our transform. And now we can use this factor directly from the geometry node modifier in order to melt our bunny. Okay, and with this, the first part of our melting setup is already done. And let's clean this up a bit. So select all those nodes and press Ctrl J to create this frame. And I'm going to rename this with F2. And I'm going to call this shrinking. Alright, so in the next part, we want to start creating the puddle that is going to appear as soon as our object starts melting. So for this, we want to bring in a new mesh, and I think the closest to a puddle is going to be a mesh circle. So let's bring this in here. I want to increase the resolution to 64 vertices. And in order to see both of those objects, we also want to add in a join geometry node. The circle is currently way too big, so let's bring down the radius. And the circle is also a bit too perfect, so let's start distorting it. This we can quickly do by adding in a set position node, and then distort this randomly by using a noise texture. Plug the color into the offset, and now this is starting to distort it, however it is way too strong. So let's fix this by first bringing in a vector math node and change this to subtract, and subtract a value of 0.5 from each axis in order to bring this back to the center. Currently it is distorting it on all axes, however we only want to distort it on the X and Y axis and leave it level on the Z axis. So let's duplicate this vector math node and change it from subtract to multiply, and just leave the X and Y values on 1 and change the Z value to 0 in order to make it flat. Now it is working, however the distortion is way too strong. So again we want to duplicate this vector math node and switch it from multiply to scale, which allows us to adjust the strength of this distortion. And in this case I think a value of around 0.15 should be enough. Then let's also fill up this puddle by changing the mesh circle fill type from none to n-gon. Okay, so now we have this nice looking puddle. However, I want it to get bigger as soon as the bunny starts to melt. For this, let's move everything a bit over, and I want to add in a new mix node that we can then connect to the radius of our mesh circle. So in the beginning it should have a size of 0, and in the end let's try 0.2, and if you play with this factor you can see that it goes from 0 to around 0.2, which I think is about the right size. Now we also want to drive this factor with the same value that we already have here. So let's press Shift A and bring in a new group input node. Then we can connect this factor up. And now you can see as soon as the bunny starts to melt, the puddle is getting bigger. If you want to adjust the size of the puddle in the end, you can simply go to this mix node and play with this B value. However, I'm going to leave this at 0.2. So now let's clean this up again, select all those nodes that we added in, press Ctrl J, and with F2 I'm going to rename this to Puddle. Now currently this puddle is completely flat, so let's add a bit of thickness to it, and in order to do this we want to use an extrude mesh node. This is way too strong by default, so let's bring this down to, let's say, 0.1, or maybe even smaller, so let's try 0.005, which looks a bit better. And by default the extrude mesh node removes the bottom part of it. So let's bring this back with a join geometry node. Then plug the original plane in as well. And we want to combine those two meshes with a merge by distance node. Alright, so now we have a bit of thickness on this puddle. However, I think it is way too sharp. So let's fix this by remeshing it. And we're going to do this by bringing in a mesh to volume node. And immediately after that, we're going to convert it back to a mesh with a volume to mesh node. Currently, this gets way too big, so let's adjust the exterior bandwidth to 0. And I think we can also increase the resolution by bringing up the voxel density to 128 to make this a bit smoother. And then we can clean this up even more by bringing in a set shade smooth node. So now this is getting better. However, I think it is still too thick. So let's bring in a transform node, and we want to scale this on the Z axis. So I think a value of around 0.5 should be fine, and now this already looks a lot better. However, I think the thickness should change as the bunny is shrinking. So let's bring in another mix node. Then also connect this factor to a group input node and use the same factor again. In the beginning, we want this to have a thickness of 0.1, and in the end, this should be at 0.5. Now, in order to plug this into the set scale, we need to bring in another combine XYZ node, make sure that the X and Y values are set to 1, and then plug the result of our mix into the set value. Now we can plug this into the scale, and you can see that the thickness increases as our bunny is melting. Alright, and now this already looks pretty good. So let's clean up the node tree one more time, select all those nodes, press Ctrl J, and with F2 rename this to Puddle Thickness. Now there is just one more thing that I want to do. If we go to the material preview, you can see that this currently doesn't have any material, so let's add in a new one, call this chocolate, and if I change this to a brown color, you can see that nothing happens. In order to make this work, we need to go to the very end of our node tree and add in a set material node. Then we can select our chocolate material, and now you can see this working. So let's also bring down the roughness a bit and maybe adjust the color to make this really look like chocolate. And now we can just play around with this factor and look at our bunny melting. Let me give you one last look at our finished node setup. So in the beginning, we created this boolean object in order to shrink our object and created this factor that we can use to control the melting of our object. Then we generated the puddle that grows as our object is melting and gave it a bit of thickness afterwards and made it smooth. Then in the end, we combined the puddle and our bunny and applied the chocolate material to our object. If you are interested, you can download this finished blend file for free with the link in the video description. If you like Blender, you'll probably also like BlenderKit. BlenderKit is a huge library with thousands of 3D models, materials, and HDRIs optimized for Blender users. Most of the assets are completely free to download. In fact, I upload my own models on there as well, so you can get them for free. And if you want to get access to the whole library with more than 20,000 high-quality assets, you can get an extra 10% discount for the very affordable premium plan with the link in the video description. That's it for this tutorial. Thank you very much for watching. I hope you enjoyed it and you could learn something new. If you have any questions, don't hesitate to ask them in the comment section. I am Nick, see you in the next one.